Hello.
It's Thursday. You know what that means? Another episode of Cloud Foundry Weekly.
Of course.
How you doing,
And
Nick?
I'm doing great. I think that intro thing, the new StreamYard feature, worked out pretty well. So
It did.
I'm looking
that's
I'm
way
looking
better
forward to
than us
using
trying to
that
do
in the
it
future.
manually.
Yeah. So props to StreamYard for a new functionality.
Yeah,
sure.
for everybody that watches, when you see the intro mess up and it starts over like 3 or 4 times, that's me. That's me doing that because I don't know how to do it right. So
Yeah.
I'm glad they automated that for us. Now they've made
Yeah.
it Mickey proof.
Very much so. Yes. But yeah, we have another, I think, very exciting guest on the show today. So back to back, I guess we'll call them legends. So do you want to, I don't know, we'll probably just get straight into it.
Dude, well, first I want to say, like you said, 2 back-to-back legends in 2 weeks, man. We are knocking it out of the park. So we had James Waters last week, and this week, author, spring extraordinaire, talk show guy, or talk circuit guy, Josh Long, Mr. Spring himself. Oh, what happened? There we go.
Hey.
Hey, Josh,
hello.
how you doing?
Good. How are you? Good morning. Good afternoon. Good evening.
Yeah, we were just talking, so everybody should know that, Josh sent us a note right before the show saying, hey, I'm in an airport. I'm rushing through TSA. I hope to be on in soon. So that may be a first for us.
Oh, well,
it all works out.
Yeah, it's fine. I was deliberating. Should I do the thing from the hotel and see if I could make the flight? Because it's where I wasn't in Denver, strictly speaking. I was in the suburbs, and Denver is nothing if not enormous. So it took 45 minutes just to go from the hotel to the airport. Mercifully, the security was good. They have historically terrible TSA here, right? It's built as a monolith, right? And I prefer the Singapore Airlines Changi Airport microservice approach. Here, all security funnels through one, or maybe it's two, TSA areas, right? And then you get routed by a train to wherever your gates are, right? And the result is that every person going to the airport goes to this one often bottlenecked security gate or area or whatever, this terminal. And then you get on these trains and they're all congested as well. So the result is just terrifically terrible time efficiencies, right? Whereas if you go to Singapore, they have microservices. Basically, each gate has its own security. And so it's redundant. It's cost more for the airport to maintain that, right? Obviously. But the result is that I'm not going to wait for any more people than there are on this flight, right? I'm not going to wait for the entire airport's worth of people. I'm going to just wait for this one flight's worth of people. And as a result, you can get from on the curb to your gate in almost no time at all, right? And there is an extra cost. There's a complexity cost to that, right? Obviously, you have to hire and train up security personnel. You have to have the X-ray machines and all that kind of stuff. And in the same way with microservices, if you have security in each service, you need to do that duplicatively. You need to do it redundantly across all your services, right? If you want to have logging, you need to have that standardized as well. And we talk about the 12-factor manifesto. It espouses a bunch of responsibilities that developers need to hew to and care about, right? You can make it better with a supportive platform like Cloud Foundry. So I guess in a way, Denver there's a reason, it's a metaphor, it's an analogy for why we should be using Cloud Foundry.
That may be the smoothest
microservices
tie into real world stuff I've ever seen. This is why you get paid the big bucks, Josh.
I got wait, news to me. Wait, they pay me in coffee, and it's not even the good stuff.
Man, just as an aside, if you ever want to have an interesting read, go and read about the back history of Denver Airport and everything that's going on under it. You know, there is a lot that goes on to Denver Airport. There's a lot of there's a lot of conspiracy theories about it, but there's also just the way it was built. That thing is massive. But I agree with you. But having to go through, you got 2 points of entry, and everybody and their grandma wants to go through those 2 points, and you're backed up, for days.
Everybody. And I have TSA pre-check and clear, and it's still just like, am I going to make this flight 3 hours from now? I don't know. Fingers crossed. I don't know. So actually, there's a counterpoint. Changi Airport, most of their gates are like that. They're redundant security gates at each, redundant security checks at each gate. So it's very, very efficient. On the other hand, have you ever been to Berlin Tegel in Germany? Same basic setup. You have gate security at every gate basically, and it's just infamously terrible. I mean, it's just one of the worst airports. I don't know how or why, but so I don't know. But most of the time, it's true. Most of the time, the extra redundant, duplicative stuff is actually better because it reduces queue time. Right, that's the whole point. Right. Same thing for microservices. You reduce time to production, time to first request.
Well, you jumped right in. I mean, the way you're able to bring that in, you jumped right in. I want to make sure we get this out of the way because me and Nick always forget it. Mm-hmm. We've got to ask you. First question we ask all the guests. Do you remember your first CF push experience?
Oh, one never forgets their first CF push. So it wasn't even CF. It wasn't even CF at that point, right? It was BMC, I want to say, or something like that, right? Because remember that technology we open sourced in 2011, right? Mm-hmm. But before that, we were developing it, and so I remember going to Palo Alto, and there's Ramne Vasladad and what's our friend? I can I'm gonna just check. Hold on 1 second.
I think we just shorted Josh out.
No, it's he's always on planes talking to people. Lovely fellow. He's been there for decades. I can see his face. It'll come to me. Whatever. There he was. There was James Waters. There was a bunch of folks, just cooped up in little. I mean, it was just this tiny little ragtag group, in the beginning. And this is back when the code was all Ruby. Right, we didn't have build packs, we didn't have service brokers, we didn't have anything. It was just this thing that was in Ruby called VMC, and it only even then I remember I wanted to deploy a brand new application using the then already released Tomcat 6, right? And for some reason, the mechanism on Cloud Foundry only supported Tomcat 5, so it wasn't even a particularly great experience for people using Spring, even though we were all in the same org back then, and we've come, it's night and day now. Now I can't imagine a more streamlined app to production for your average Spring developer. But back then it was like, oh wow, there's lots of opportunity here, lots of possibilities, but it was a little rough. I had to use an older technology so remember, we are the main contributors to Tomcat and to Spring, and we were the main contributors to Cloud Foundry at the time, since we conceived of it at VMware. Mm-hmm. And and I was like, well, why doesn't this work? Why isn't this flawless? The team was it was so small. They were supporting so many different tranches of opportunity, or pursuing so many different little threads. Those are rough and tumble days. So I deployed an app, just a web app, just a Spring MVC Tomcat app, in 2010, and it's like, wow, I didn't like having to use older version of Tomcat, but it worked. It worked so well. I had a URL, I mean, right. And this is before it was open source. This is before anybody knew about it, right? So early days yet, obviously. And and that was on Ruby code. Have you ever used Ruby? It's not a thing. One does not simply use Ruby. Back at the time we had not for operating systems. I mean, come on, I'm not going to build my next operating system using HTML either. There's a reason. I need types and efficiencies,
Right.
So yeah, it was just an incredible result. These geniuses and I make fun of Ruby, but I gotta imagine it allowed us to prototype the space, to explore the space, to get a result that was reasonable more quickly than in any other language of the day. Right? Go wasn't a known quantity or commodity at the time. Java was, nobody wants to ship a JVM, right? And the same, but on the other hand, they shipped a Ruby VM. So I don't know. What do I know? Yeah, just an amazing result. And then of course a lot of that has since been rewritten in Go, right? Which makes a far more sense. Yeah, just that. I don't know. That was my first experience. It was magical. It was just this uncanny feeling of like, wait, I could download that thing and set it up in my home office, and I could have a cloud, and like nobody's gonna stop me. I don't know anybody any money, and like, okay, that was yeah. Actually, I guess the not owning money thing came a little bit later because they open sourced it in 2011, right? So I guess at the time, I don't know what I thought about the pecuniary dollars and cents of it all, but I was still utterly impressed by the fact that I could download a thing, figure out how to get it installed, and then emerge on the other end with my own cloud. I could be a cloud provider. I was like, oh, this is super duper neat. Oh, well done.
Well, and that's interesting. You went from, hey, my first CF push wasn't all that great because I had to use an old version, right? But then you wrote a book, right? With, I believe it was Kenny Bastani. You wrote a book on how to use cloud native Java on Cloud Foundry. So must have made a hell of an impression.
Well, so I mean, even that again, the team that was working on it were people who were in the Spring team. They got why this was so important, and they understood. Like that got fixed. They moved to Tomcat 6 very shortly thereafter. But much more importantly, they introduced the concept of a build pack. Right? Like now it's pluggable. Now if I don't like what they're using, fine, just provide my own build pack. That's way, way better solution, right? Because at the time it was as good as the pre-programmed prescribed sort of solutions were, they weren't necessarily what I wanted, right? So in the next, and when I say soon, I mean in the next 6 months we had, memory fails me sometimes, but it could have been like we had a build pack, service brokers came along pretty soon thereafter. We had just a lot of stuff came together in those next 6 months. It sort of congealed, and a huge part of that, obviously our friend James Waters is, he was beating the drum. He's like, we got to get this thing askew, and it's got to be real. Let's focus on delivering something that people can use and benefit from, and it just went from a really interesting, albeit sometimes academic research project to like this thing I would want to run my apps on and I would love to deploy myself, and it made me love that 12-factor manifesto. That's the other thing is the 12-factor manifesto espoused a bunch of principles that were for the programmers, for the software people. But what is left unsaid, but I think well understood, is those things don't work unless something provides them, right? Like if I, as a programmer, I'm told, okay, just write out logs to standard out. Yeah, but who's going to do anything with that, right? The platform has to know to slurp that up and then ship the log somewhere, right? I'm told, okay, write my code such that I depend on environment variables, externalized configuration. Sure, but who's going to provide the environment variables with my credentials? The platform tells me to have one build and then promote it, right? Okay, but again, what does that look like? All these great principles that implied another 12-factor. It wasn't the 12-factor app, it was the 12-factor platform. They are mirror images of each other, yin and yang. And Cloud Foundry brilliantly just provided all those things. If you wanted to do 12-factor apps, you needed a 12-factor platform.
And that's one of the things that we always talk about that we loved is, it enables developers to get their code out there quickly. But, both Nick and I have a background in operating the platforms. And
so good.
I love to say that I'm not a developer. The fact that I could run the platform and help these guys out and be able to provide what they needed to get their code out quickly without having to really understand what they were doing with their code, that was a huge benefit as well, man.
There's a little bit of learning for both sides. Yeah, for sure. Like we had to learn how to write 12-factor apps, which is there's a reason there's a manifesto, because that was not what was being done. We had to meet in the middle there. But once you're going to meet somebody, you can go to like a bar or you can go to Cloud Foundry, and I prefer Cloud Foundry. Production's really nice, It's a great meeting ground for developers and operations. Yeah, I'm a big fan. That was, and now I've having been through the what I was about to, that we used to have a code name called Rubicon. Do you remember that?
No.
A code name or like a
yeah. I don't know what that was. It was like it was a part of our effort or whatever. Anyway, we had this. I was just saying, having gone through the Rubicon of Kubernetes and having seen what it is to deal with more primitive atoms for building applications and all that. I just appreciate Cloud Foundry even more now. Kubernetes obviously has its place. Obviously, it's really good at a number of things. But if I just want to get an app up and running in production, which is what most of us want, there's nothing like that, like butter smooth the experience that Cloud Foundry gives you. And yeah, you're right. I wrote that book. Yeah, go on.
I was going to say, well, I mean, we're talking about, we've always said that Cloud Foundry is the best place to run Spring. You've kind of went over how those two things mesh. What advice do you have for developers out there? What are some of the best practices for writing Spring on Cloud Foundry? Are there tips and tricks, or the things that make it easy, or is it just inbuilt into both Spring and the platform that they just work well together?
Yeah, like I said, there was learning on both sides. So Spring Boot really changed the story for us. So historically, Java and Spring apps ran inside of something called an application server, right? And which is a little ridiculous when you think about it, right? You in order for a Java programmer 20 years ago to ship something into production, they took their program code and then wrapped it in the application server sandwich, and then they took that and then deployed that to production. And they thought, well, okay, in order to get reuse and efficiencies, we will have multi-tenant application server, so you can deploy two apps to the same sandwich, basically, to the same wrapper around these apps. And the application server provided, it was supposed to provide some services to these applications, common services, like a directory, a namespace in which to look up other services, and connection pooling. Well, it turns out these are not hard things, or in the case of the directory service, a required thing. Nobody asked for it, nobody needs it, nobody wants it, nobody cares about it anymore, right? So a lot of those things we pushed down into Spring, so that now we didn't need to. It wasn't like you needed, like back then, that meme of like you complete me. That's true for a Java app back then. You needed the app server, otherwise your app didn't do anything. It was inert. But now we have Spring. Spring pushes all that stuff down. Spring Boot pushes all that stuff down into our app code. It's just a dependency on the class path. And so now I can build a standalone self-contained app. In order to run it, I need the JRE plus my app. That's it. I don't need an application server in addition to my app and the JRE, right? And actually nowadays, today, we can build statically linked self-contained native image binary. So actually I don't need the JRE at all anymore either, right? I just need my app, right? And and these are more standalone sort of things, like a Go program or a C program or whatever. So I just think Spring Boot really, it sort of pulled together some of this really well-received wisdom around observability, around standalone self-contained binaries, around security, around all these things, and productize them. They're now the default opinions. They're weakly held. They're strong opinions. They're weakly held. You can override them at every step of the way. There's no reason to be stuck with one of Spring Boot's proffered opinions, right? This is in stark contrast to the likes of Ruby on Rails, where if you want to unwind that selection, that choice, you went from flying, sky high to having to go down in the weeds again to undo that assumption, right? Whereas with Spring Boot, you can more granularly pull back or disengage individual objects in the object graph and make things do what you want selectively, as opposed to whole features being unwound. So all that to say, it took Spring Boot for us to really get in that groove where Cloud Foundry was just such an obvious and natural win, because Spring Boot codified a lot of these 12-factor manifesto patterns, right? By default, you got them, and that works nicely with Cloud Foundry. It works nicely with any smart platform in theory. We didn't just build it for Cloud Foundry, obviously, but it didn't help that it didn't hurt, obviously, that Cloud Foundry was really, really good, and it knew exactly what to do with these apps, yeah, I don't know. So for a Spring developer today, you don't have to do that much different because Spring Boot will just do the right thing for you out of the box. That's I guess what I'm trying to say. The long way around is it took a little bit of time for us to unwind these default Java idioms. Where if there were a word that combined idiocy plus idioms, that was the stuff that we were doing before Spring Boot, and and now it's just I don't know, it's just really good. Now you have these self-contained jars. So what else do you need to know? There's some complexity implied in building distributed systems, as our friend Matt Stein used to say. You need to be this tall to ride the ride, right? There's some complexity in building distributed systems and cloud native systems and the like. And so things like service location, centralized configuration, things like routing, things like load balancing. These are things that you need to care for, and it's better actually if you handle that stuff to the extent that you can in your program, in your application logic, as opposed to getting a one size fits nobody prescription at the platform level, And so CloudFoundry does a very good job of some useful defaults here. But again, with Spring Cloud, you can build microservices and leverage the Spring Cloud config server, which is infrastructure. Well, happily, CloudFoundry supports standing up that infrastructure, right? If I want a service registry for service registration and discovery, well, happily, CloudFoundry supports spinning up that service registry, right? It knows exactly the mirror image. I know that I need that as a client. So CloudFoundry knows I need that as the infrastructure, Yep. And so taking advantage of that's really useful. The cloud native style,
Well, and we've had Deshaun on talking about all the virtues of Java 21 and AOT compilation. I don't know if you got to watch. We had Mark Fines on, who went through his thought experiment about how to take a running application and compile it into native image.
Native images,
and get all of the benefits, but to do that without really having to bother the developers that much. But that's a huge advantage right there. And the fact, we've got build packs that are coming out with the latest version of Cloud Foundry. We're supporting native images, being able to take those applications that we're running at 1 gig in memory and taking them down to 300, right? And
or
sub-second startups.
Yeah. Like it's phenomenal. And you're right. So the native image thing, that's Mark Fines showed that to me as well. And, late last year, I think, or early this year. And, it was, because did you see him do it locally on the machine, on his own machine before he did it in the cloud? Okay, so there's like 50 seconds of dead air, right? When you're doing these native image compilations, you're just sitting there waiting, right? It's the worst. It's the worst thing, and but it's something that you need to do to get that production, right? And I just love that I can just offload that to the platform, let it be somebody else's, because the compilation is like really gross, right? The compilation takes a megaton of RAM, and so I can't run. I've only got 128 gigs of RAM. I can't run Slack and do a native image compilation. There's not enough RAM,
Right.
So I got to shut down something, and I don't like having to do that. It's not good. So having the platform to manage that for me, thank you, Cloud Foundry, thank you so much.
Well, and that was one of the things that I really liked about Mark's demonstration the most, right? Is we do have a lot of developers out there that are coming back and saying, hey, native, it's great. All the benefits are awesome, but man, it takes so much to compile it and get it ready. Well, with Mark, he showed, within Cloud Foundry, you only got to compile it once. Once you get it compiled, you download the droplet and then you can upload the droplet, and you're not having to do 20, 30-minute compilations in production. You're only doing that, at a build time, and you only have to do it once. It's a one-time cost if you use the droplet feature. And that's awesome. That is absolutely, that's something that's game-changing, that lets, the native images be something that you can use without having to worry about those huge compilation times.
Huge. And that compilation time, like I say, it's my least favorite part. Can I share my screen? Let's see here.
Oh, for sure.
It's
shout out to all the comments right now. Thanks for the live watch, live viewers.
Okay, there we go. You can see my screen. So native.
Hold on.
Oh, we gotta add it, don't we?
Yep.
It's inception mode right now.
Yep.
Can you add it to the screen?
Yeah, we can add it to stage.
Stage.
I hope you see it. I don't see the add to stage on there.
It's on the bottom next to my name. There you go. Okay. So the native image compilation is my least favorite part of the GraalVM native image compilation. And the problem is I get really bored very easily, right? I get very bored because if you saw, it takes a long enough time that you're sat there just sort of waiting for something to happen, but it's not long enough that you can go do something useful like hit the washroom or make a cup of coffee, right? No biological IO allowed. And it's not like you can go take a walk or do something like that. So you end up just sort of stuck there waiting. And it's also short enough that like I said, it's short enough that you can't do anything interesting, but it's also long enough that you're sort of arrested. You're just unable to proceed forward and do or contemplate anything else, because then you'll get distracted, right? And I don't like that. I get very bored very easily. And so I feel like I understand finally this famous XKCD cartoon. This is this cartoon, xkcd.com 303. It posits that the number one excuse for legitimately slacking off is my code is compiling. These two yokels are swashbuckling on their office chairs, and the boss says, "Hey, get back to work, compiling." Oh, carry on. I get that joke now. I didn't want to get that joke. I thought this is just for the C++ people, but now here we are. I get this now, and it's very unfortunate. And the compilation time just takes endless amounts of time, and it reminds me of that interminable sort of endlessly looping music that you hear sometimes in elevators in very tall buildings, right? And remember, it's elevator music because it's distinguished from, say, regular music that has a well-defined start and stop. They don't want you to know that you've been on this elevator lift for like 2 Taylor Swift songs, right? They just want you to know you're listening to something vaguely pleasant. And so they call it elevator music. And it reminds me of that interminable elevator music, and I hate elevator music because I hear it in my head now when I do these compilations. So I thought, maybe wouldn't it be great if everybody could hear elevator music? And so I went to Oracle and I said, Oracle, please play elevator music during the native image compilation process. And I asked them, I said, I already hear elevator music in my head when I do these long running compilations. I just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work, right? And I do, by the way. This is GraalVM, the technology that we're talking about is an Oracle project, and I do, and I appreciate what they're doing. They're doing good stuff over there. And then somebody said, our friend over at Red Hat, Andrew Din, he's a distinguished engineer on the Red Hat Java team, OpenJDK project reviewer, Byteman project lead, and Graal developer. And so clearly this was a good use of his time. And he said, can you make it this elevator music? I don't know if I can play this, because what this is it's a link to the YouTube video, to a YouTube video that has the soundtrack from the first Pierce Brosnan outing as James Bond in 1994's GoldenEye. There was a Nintendo 64 video game adaptation for GoldenEye, one of the best games ever made. And in that video game, there's a soundtrack, and in that soundtrack, there is actually really great elevator music. So I encourage you to click this link on your own at your own leisure. And I
thought you had taken it somewhere else. I thought that elevator music was going to be like a Rickroll, right? You were going to
no. I should do it. Oh my God, I should get that changed. And so somebody else said, hey, I would add that using beeps in general, not only for native image, really helped me to reduce development time. I love this idea. What they're saying is basically it should be like a microwave, like my multi-million line compiler can make a ding sound when it's done, so then I don't wander off too far from my desk, and I like this quite a bit. I thought that's a great idea. That's got legs. Let's do that one. And then I get this response, and this is from Dr. Fabio Niephaus. He's a researcher on the GraalVM team at Oracle, and he's one of my favorite doctors, along with Doctors Who, Seuss, Strange, Subramaniam, Sire, Pollock, DeVolder, and now Niephaus. And he said, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Okay, go on. I have prototyped a -- Josh long mode. So what this would do is you run the native image compiler -- Josh long mode, and then you pass in the code you want to compile, and it plays music. This is a picture, but don't let that stop you from perceiving that there's music playing at this point, right? And you're like wondering, okay, who did this to me? Where's this music coming from? What's happening? Am I having a stroke? And then so the thing would print out, hey, no, music brought to you by Josh Long. So now you know what's going on, and you're like, okay, I'm cool with that. I know what's happening, but I'm still waiting, and you might want something nice to look at. So it would print out in this proposed PR. It would print out me basically in my Spring T-shirt. So anyway, I'm not sure when that'll get merged in the compiler at Oracle, but I have hope. Hope springs eternal, right? And anyway, that's great. I don't want to have to worry about all that. Is my point. So I'm glad the platform will do it for me.
That's amazing. I wish I had the reach to have somebody put me into a compilation step.
Believe me,
that's amazing.
It's a demotion. You don't want people. You know how sad that is.
Josh Long mode. That's. We'll all keep our fingers crossed that gets PR'd in.
Yeah. I love we have the best communities. I love our communities, man. The coolest people work on it.
Speaking of finding,
side note.
Mark.
Yeah. The GoldenEye game actually got re-released too, by the way, for modern platforms. Yes.
Really?
Yeah. Yeah, you can play it on Xbox and anything. Yeah. So
Mr. Stumper.
Yeah.
CF Haiku for 2024. Here's my code. Run in the cloud for me. I don't care how. And while you're at it, could you shrink my memory demands down 90%? Yes. Is that a haiku though? That doesn't. I think you cheated a little bit. But I get what you're saying.
It's a haiku for people that don't know what haiku is.
Yeah. Hard day haiku. No, I want the platform to do more. Is my point. And again, it's a function of like how fast. Because you can only do so much with what you're given, right? The platform is doing everything it reasonably can, but Java didn't develop this ability to have these native images. And Spring in particular didn't really start developing it until a year and a half ago. A year and 3/4 ago. So yeah, it's a new thing, and the platform's already meeting us where we are and optimizing for that particular pathway. Really, really good.
Well, and I guess that takes us in the next question. I mean, we're reinvesting into Cloud Foundry, or we're reinvesting in the Tanzu platform for Cloud Foundry. Are there any new features out there that really got you excited?
That was you spoiled my thing, right?
That's what I do, Josh. That's what I'm here for, man. Spoil people's things.
Yeah, no, I was going to talk about the native image because that's that to me is exactly why you want the platform. We get the recipe right once. And it's reusable on the entire platform. That's everybody using the platform benefits from it. And it redounds to all of our benefits. So actually I just want Cloud Foundry back. I just want that consistent experience. It's really, really important.
We were talking when we were talking with James, right? We
lost the AI stuff too.
Yeah, we lost sight of the whole platform as a service. We lost sight of how important platforms are. We're seeing platforms come back. I mean, even the public clouds are starting to do their own kind of versions of platforms instead of just IS. So, it's like me and Nick like to say, right? Everything old is new again, right? So tPCF is coming back.
Yeah. Well, even Heroku's, I think, going to update the 12 factors or something. I saw a post about there to get a request to help update the 12 factors too. So
let's go. I mean, hey, I think people are just. I think there's a little bit of a blowback here. People are looking at come on, the CNCF chart, the CNCF landscape diagram is a fractal. The deeper if you click on it, it fractals out into more icons, right? It keeps going into infinity. It's too much. I don't care about any of this. I want to go to production, And while I grant that it's possible to build anything you want on top of a Kubernetes, I don't want to build. I mean, I got other things to build that are actually product revenue generating things, and I just don't care. I do not care about people who revel in YAML. Do it on your own time. I don't care what you do in the privacy of your own bedroom, but I don't want to know about your YAML, at all. I want to go to production. That's great.
Josh Long and Deshaun. So Deshaun always says, "Don't let friends, friends don't let friends do YAML." Josh Long is, "I don't care what you do in the privacy of your own bedroom with YAML." Right? So.
Yeah. Just don't bring it to work. I don't care about that. It's not interesting to me. I deliver software to customers. I don't care about building a platform on which to do that. That's, don't build what you can't charge for. Is the other way to put it, right? If I'm building the platform is not why I'm here. Unless some of us should be paid to do that, but the rest of the ecosystem does not care, right? Our customers do not care. The economy, most of us don't care about that platform. It just should work. And if it doesn't work, then you'll hear from me.
Well, I mean, you brought it up, so let's dig into it a little bit there, right? So Cloud Foundry versus Kubernetes. Kubernetes is out there. All the Spring projects, have Kubernetes operators out there. Well, I won't say all of them, but a good portion of them. I mean, what are your kind of thoughts on the developer experiences between Cloud Foundry and Kubernetes? Kubernetes is kind of the new shiny. Everybody wants to do it. It's Google, it's Netflix. Hey, we should probably be doing it too. But we know that there are some developers out there having challenges kind of moving their mindset to Kubernetes. What is your thought process on this?
It's by default, there is no developer experience. You have to build it. That's what I'm trying to say. Is most people build this? They have this fragile cargo culted pipeline that serves as a, what's that quote? Something about like a half-baked, buggy, bug-riddled implementation of Erlang, whatever. Every distributed system is a half-baked. Is a half-baked, buggy, bug-riddled implementation of Erlang. Like, you're gonna try to build in some of that sweet pipeline goodness on top of Kubernetes, and you're if you're smart, you know what good looks like, you know what Cloud Foundry looks like, but how do you get there? And do you have the time to do it? Because I know literally, I don't know how many people, tens of thousands of people that have been involved in Cloud Foundry over the last decade and a half. You think you're going to duplicate that in a pipeline tonight on GitHub Actions? Good luck. It's ridiculous. Kubernetes is great. I like, again, but it's not the thing I care about. It's not how I get to production directly. You know how long it takes for me to? I'm not a stupid guy. I'm not particularly smart either. It took me a long time to learn all the moving parts of the average Kubernetes cluster, right? And again, I get granted there's a world where that's something somebody should do. It's just not me. It's just not me. I don't care about it, not one bit.
Huh? Makes sense. Well, and you brought it up, so we got a question from Chris Phillipson. What excites you about Gen AI on Cloud Foundry? What are the use cases?
Okay, so this is one of those other things where, again, I want the platform needs to meet me where I am, right? Right now, all my apps have a use case for AI, right? Obviously. So we have this project called Spring AI. I just want to connect my applications to some of these models, right? And there are many a model out there. Having a hub, a broker, something that'll make it easy for me to spin up and then connect to and integrate that into my applications. It's a stateful service. There's a lot of moving parts to that. Let that be a platform concern. It's not mine. I want to integrate that into my app, here I want to just quick shout out to Spring AI. Spring AI is, it's the best vehicle that I know of right now for people to build generative AI applications. It codifies for the average Spring developer, which is to say the average Java developer, the patterns of AI engineering. And to the extent that your business logic in the enterprise today is delivered as a Spring application, and your data is being guarded by services written in Spring, the most natural place in which to sort of integrate AI into your applications is in those services, because all your business logic and all your data is already there anyway. And Spring AI makes that easy as pie. So I really love, the idea that I can just build these applications that leverage these AI engineering patterns and spin up something like the Gen AI stuff on Cloud Foundry. That's exactly what I want to do, and it's already here before I know I needed it.
Yep. And since we're doing shout outs, I'll give one out to Adib, because we did a show with Adib where he's starting to walk us through. We're going to actually turn that into a series of shows where Adib's going to walk us through Spring AI, using Spring AI use cases. So, we'll put a link to that episode down in the show notes for this one. But yeah, if you're more interested in what we're talking about there, go see the Adib and make sure that you sign up so that you can see the next session that Adib does with us.
Yeah, absolutely. Good stuff. Oh man, I'm so excited. This is we've been on the air for 38 minutes. You know how many applications I could have deployed by now? It's ridiculous. It's just stupid.
Yes, there's going to be another quote. We're going to get a lot of quotes out of this one.
Yeah.
Absolutely.
No, I actually have I had a manager decades ago, long before I joined the Spring team. That was a very highly strung, and he just did not suffer fools gladly. Had absolutely no patience for people who reveled in technology over solutions, and so on. And I don't know that I would ever. I hope I'm never so highly strung. But on the other hand, I do find this whole. I cannot believe how far afield we've gone as a community in the last 10 odd years following. I like Kubernetes, but again, I don't think it should permeate every person's life. It just shouldn't be that front and center, just such a, what are we doing? I've lost count. I don't even know what the big picture is anymore. We had the basic Atom, but we need to stand up a web app with a load balancer and an ingress in Kubernetes when on day one, right? It hasn't gotten that much better. What does all this other stuff do? I don't know, and I don't know, man. It just frustrates me to no end.
Yeah, I think some of that is, I don't know, maybe being course corrected with this generative AI like push, so to speak.
Yeah.
Because now it's just like, all right, well, we have this I got a new shiny, let's just call it.
Yeah.
And then there's all this, new promise or new application use cases around generative AI, and like, building your own platform in Kubernetes isn't as exciting to people anymore.
Yeah.
So
well, I mean, that's because the new shiny is.
We could, retroactor.
The new shiny is actually helpful,
recalibrate.
though, right? So the new shiny that we're getting with Gen AI, I mean, it's actually solving some really good use cases, and it's augmenting things that people are already doing today. I think that's one difference. I mean, to be honest with you, but again, it goes back to it is the new shiny, and I've talked about this. Nick's the AI guy, but I see people throwing AI into everything in the places that it doesn't even seem like it belongs sometimes. So, be AI responsible, people. Have a good use case. Be responsible with your AI. Don't just put it in there because you can.
Yeah. I mean, so I live in San Francisco, and it's really cool. It's really cool, actually. But it's also, you're right. There's definitely some hype that I hope will deflate a little bit, and will the dregs will sort of disappear, and we'll see what's actually good. We'll separate the wheat from the chaff, right? Like, but in San Francisco, there's this energy that hasn't been there in a while, where you can just go into random like coffee shops and you'll hear people talking about AI. Like not even particularly like IT or Silicon Valley centric places. It's in the air right now. It's in the water. And I'm really glad, because the last time I heard people coming even to the precipice of this kind of excitement was like around some nonsense, honestly, like Bitcoin, things like this, like a Web 3.0 blockchain. I'm so glad that's gone. Like, I'm so glad that's not what we're betting the proverbial farm on anymore. AI, at least I can see some useful applications out of it. But yeah, I do think there's going to be sort of and by the way, the fact that we're in the Java ecosystem and we're integrating this stuff means that people have already found some valuable use cases, right?
Absolutely.
It's in the enterprise, the enterprise is not like I like to distinguish between Silicon Valley. Do you remember Steve Yege? He was an engineer at Google, and he gave a talk at OSCON like more than a decade ago, I think. And OSCON was a now defunct open source conference, for those who didn't know, run by O'Reilly at the time. And Steve Yege gave this talk where he talked about how, like, we live in this era where we have abundant access to easy knowledge everywhere. I can buy a book and learn whatever I want, statistics and maths and science and whatever. I can do that anywhere. And yet so much of Silicon Valley was focused on building what he called cat picture websites, like, right, as a derogatory term, like basically stupid stuff. We had all these smart people building nonsense, and so I think about the cat picture website contingent versus the enterprise, right? And so there used to be this very sort of, I mean, there still is to some extent. There's this ugly sort of air of superiority that you get when you talk to people in Silicon Valley who chafe at the idea of the enterprise, And I just think that's really, I mean, people in New York building for high finance, or in London or Singapore, are doing things that are just as cool as any Google, as any Meta, I mean, these are applied sciences. These are applied industrial sort of things they're doing here. And those are very interesting. So to see AI now starting to make its way into those enclaves is super exciting to me, right? That means that there's really valid use cases out there.
And I want to be very clear. I'm not knocking AI. I use AI.
Oh, sure.
I think it's awesome, right? I do think that, it's one of those things, because it's the new shiny. We are seeing a lot of people that are throwing it in there to get the checkbox looks. I did something AI. But what really excites me about like Spring AI and the ability to bring in LLMs, as a service into Cloud Foundry is it's opening up the ability for some of those developers, some of those smart kids that are out there that have a great idea to go and do those ideas. But just because you can doesn't mean you should in all cases, right? Have a good use case. Don't just throw it in there so that you get the check mark on your resume.
Oh, yeah. Yeah. Hype-driven development. Yeah, for sure. I agree. That's what I'm saying. That's why when I started to get excited was not when AI first appeared. When I got excited, when I started to see people in like banks have ideas about it, right? Because they're not going to do it unless it's scalable, reliable, and safe, secure, right? There's usually legal consequences if it's not, right? So they're very, they got to find a way to make that work. And I love those kinds of use cases. If they can make that work, then I'm all in. That's cool as heck.
Yep. We're going to digress just a little bit. So Chris Phillipson, after what you said, he threw down the gauntlet for you. How many apps can you deploy in 30 minutes? Have you ever counted from scratch? He's throwing down a challenge for you, Josh.
I did this. I don't know. Okay. So first of all, for people who don't know, if you're using Cloud Foundry, you could have a jar with a web app with a hello world endpoint, and it would be CF push space, my app.jar, right? And then give it a name. So I guess there's a name in there somewhere as well. So CF push name and then the app jar, or is it the other way around? I always forget. But basically, you specify the name and then the artifact. So to the extent that I could do a for loop and launch a bunch of shells, I could probably get thousands of apps going in the next 30 minutes. And as long as the platform, the cluster to which I was deploying had enough capacity, I would get them all deployed in those 30 minutes. But more realistically, my book, that Cloud Foundry and Spring Boot book, Cloud Native Java from O'Reilly from 2017, every book's code was a GitHub repository, and every chapter's code. I mean, all the code for each chapter was in a GitHub repository, and so that meant that if I had whatever number of chapters, I had that many or more repositories. And each repository, sometimes they'd have it's about microservices. I'd have 5 or 6 apps in each repository. And whenever I made a change, I stood up, I would deploy, stand up, and do integration testing on Cloud Foundry, all these different services. And I do that all the time. I could easily deploy 100 different things in a day just automatically by making changes to my book and the code that accompanied it. This thing would just go to Cloud Foundry, do its thing, spin up, and then destroy. I was using the Reactor-based Cloud Foundry Java client to orchestrate this stuff, and that was it was just trivial. It's trivial. So you're asking how many can I do? Yeah, I mean, as many as I want, really. The platform will meet me where I am. I've never been able to stump it or overwhelm it.
Well, and we'll link to those books because, again, I am not a developer, but I read You're Getting Started with Spring Boot 2 just so that I could understand what my developers were going through and some of the things that I might be able to do to help. But we'll link where your books are. If anybody's out there, if you're a Spring developer and you haven't read one of Josh's books, then shame on you. You probably should be.
Or maybe help. You're really smart. I don't know. In general, there are better things you could be reading than my stuff. But I appreciate that. But actually, the book I don't want to scare people. This is the thing about Cloud Foundry. You don't need the whole book. Actually, for the 80% case, you really just need those 4 words I just told you: CF push space name and then jar. Right? For the 80% case, you're going to be fine there. You might need to create a CF create service and then bind. That'd be a 3-liner script there. I don't know. Yeah, don't let the fact that I wrote a book about it dissuade you from learning the technology. You don't need a book. That's why I wrote a book about it. It's because it's so easy. I could focus on everything else.
Well, he's being humble there. Again, not a developer. It helped me out. I'm sure a lot of people get some use, but it'll get you started, and that's where we want to get people. And if you're a company that's using Cloud Foundry, not only is Spring easy, but getting it deployed is easy. Making sure you can innovate is easy. So it really kind of a no lose for developers out there. And Spring's Java's kind of taken over the world right now. Where do you see the future of Java going?
So the Java team, so Sun, Oracle bought Sun, 2005, 2006, something like that. So Java's been under Oracle for most of the time that it's been out there. Java's now next year will be 30 years of Java, right? And my talk track these days, the thing I go around telling people and reminding them is that there's never, ever been a better time to be a Java and Spring developer. It's actually much more interesting now than ever before. And that was, if the conference scene is nuts right now. You can see people talking about amazing things, and all the time there's Java in there somewhere, and I don't know. The Java team there was a bit of a stagnation right after the Oracle acquisition, and then they really kicked it into overdrive around the Java language. The Java language and the platform really just went further and farther and faster. So to give them endless kudos and credit, they've just made this language really, really good. So you heard about virtual threads. Virtual threads are a thing that was introduced a year ago in Java 21, and I don't know. When I think about production, I think about three things. Is my application efficient? Actually, can I share my screen again?
Yes, sir.
Yay. Can you just add me back to the stage, please? Woohoo. Okay.
Ooh, Inception. Let's get you somewhere. There we go.
So I think about three things when I think about moving my application to production. And Java scores well in all these things. The first is my app efficient, right? And so there's this great blog from 2018 before the COVID pandemic or BC, which asked the question, which programming languages use the least electricity? Okay. And this is 2018, mind you. So the table is kind of interesting here. You've got C is the most energy efficient for machines, not for people. Definitely not for people. For machines, okay? Most efficient. Rust 1.03, zero cost abstractions, doing quite well. Well done, good on you. And then we got C++. Ooh, disgusting. Moving on. We've got Ada, nobody cares. And then we have Java, right? And Java is like in the top 5 most energy efficient languages out there. And this is 2018, 6 years ago. It's only gotten better. One thing to note, of course, is of these top 5 languages, the first 4 are compiled, and Java is a virtual machine. Mm-hmm. So one wonders what would happen if Java were compiled. That's called foreshadowing. Okay, friends, that's foreshadowing. So we'll move on. Then we've got C#, Pi. That's nice. I like that. We've got Go, Away. We've got these disgusting languages. The list said about what's the better. This whole thing just makes me itch. Moving on. And then you've got JRuby and Ruby. Now, JRuby is Ruby on the JVM, and Ruby is Ruby just in C. And JRuby on the JVM is almost a third more energy efficient than Ruby in C. And there's a lot of obvious reasons for that. First of all, if you've ever done any C programming, you know that there's something called RAI, resource acquisition is initialization, right? And it's the idea that you allocate a bunch of memory, do something with it, and then immediately free it up because it's otherwise going to become a leak, right? And so yeah, that allocation and freeing is actually very expensive, and it's not energy efficient. Whereas with Java, you start up the JVM, it mallocs a bunch of memory, and it just doles out chunks of that slices of that giant pie through the execution of the program. So you get much better efficiencies. That's my guess. I don't know. The point is, by building on the JVM, by dint of having been built on the JVM, JRuby is actually a much more efficient language than Ruby. Okay, and then of course you get Python. Oh, Python is this bothers me because I'm a big Python fan. I've been using Python since the 90s. Huge fan. I learned Python when Bill Clinton was president, right? Like I'll never forget. So 75 is round up, call it 70, 76, and then here's Java. Let's round up, call that 2. So basically Java is what is that? I'm not very good at math, but you know who is great at math? Freaking Python, right? So I go here and I do 76 divided by 2, 38, right? It's 38 times more energy efficient than the average Python program. So, if you want to save the turtles, use Java. Okay, so that's part 1. That's the first thing I care about is energy efficiency. Part 2 is my code scalable, right? And, we have virtual threads now, right? So to the extent that Java programs execute quickly, I can finish more work and then start doing more work, and that makes me scalable. But there's a lot of externalities in the world that I don't control when I write a Java program, right? Like how long it takes for a service I'm connected to respond, a database, an OpenAI or LLM or model or something, a microservice, whatever. All these different externalities that take the time that they take and no sooner. So to the extent that those things are beyond my control, I have to be wary of how long I spend waiting for those things to happen, because that means that that time spent waiting for those things to happen will happen on a thread, and threads up until Java 21 were a precious and rare commodity that you couldn't just count on being infinite, right? And so we do all these things to sort of avoid sitting on threads doing I/O, because I/O is not CPU bound work, and there's no need to be bogarting these threads, which are, after all, the vehicle by which we access the CPU, and the only way to access the CPU. We don't want to sit there wasting time waiting for bytes to come back across the wire when we could be using those threads to actually do stuff on the CPU, right? And so the question is, can we write our code in such a way as to not sit on that thread, monopolizing that thread and frustrating other parts of the system's ability to access the CPU? And so we embrace non-blocking programming, and that's reactive programming and the like, and that works, but it's a different paradigm. So in Java 21, the Java team shipped something called virtual threads. Virtual threads, basically, you change nothing in your code, almost nothing, right? Like literally a switch, and suddenly the threads that you're using when you answer a HTTP request into Tomcat, or use @async in a method signature or whatever, all these things are suddenly now executed on these new magical virtual threads, where if you do a thing that blocks, if you do a thing that sits there and waits for bytes to come back and forth over the wire, the runtime detects that and moves you off of the thread and into something else, right? Into RAM, basically. So like, it's an amazing result. Like the result, I mean, truly an amazing result. Like the result is I'm no longer blocking the thread. The system gets that thread back. I get the same sort of scalability as you would with Go, albeit with far less code, right? This is the first time in the history of Java where we can say that. We can say, hey, this is actually much nicer than the equivalent features in other languages. It's actually much more concise than the equivalent features in other languages. And I just want to point that out. I want people listening to enjoy it, just soak it up. It won't happen again. Like Java is nothing if not slow to evolve new syntax and features, right? So this is actually one of the rare wins where we can say, yeah, async await in C# or Python or JavaScript or whatever. This is better, So there's that. So yes, it's scalable, right? We have virtual threads. It's super scalable. If you want to use that in a Spring Boot app, you just say spring.threads.virtual.enabled equals true in your application.properties, and then you're done. If you've got Java 21, that's all you need to do, right? You've got a much more scalable application without any refactoring or any permeating changes to your code. That's very important. And then the last question is my program fast? And you may have seen this. This is the 1BRC. This is the 1 billion row challenge that was spearheaded by my friend and fellow Java champion, Gunnar Morling, wherein he asked people to submit programs using stock standard JDK, no libraries, no frameworks, nothing. And he asked them to submit submissions to see how fast a program could load 1 billion rows of weather station telemetry data. So cities plus weather, okay?
Mm-hmm.
Now, how fast do you think the fastest program was?
No clue.
Like it's 1 billion rows. You have to do some statistics on each. It's the city, weather, temperature or whatever. You have to do some statistics, print out the results, and then exit the program. And that 1 billion rows is about 13 gigabytes of text. How fast? Take a wild guess.
I'm gonna let you take this one, Nick.
5 minutes.
Okay, that's pretty.
Yep.
That's pretty. That's pretty good. The answer. The fastest entry. Hello. Fastest entry was 1 second, 0.5.
Wow.
1.5 seconds.
Whoa. Okay.
Yeah, in Java. The second was 1.58. The third, 1.6. And the fourth, 1.88. Now, to be fair, these first three are all using GraalVM, native images, the native image technology about which we just spoke a minute ago, right? Mm-hmm. And then this fourth one is using regular OpenJDK. So even regular OpenJDK is super fast, but the real like heat comes from these first three in native images, right? So when you talk about CloudFoundry can automatically turn your app into a native image, that's what we're saying is we're giving you industry class performance that will far exceed almost every expectation. Now I'm being a little disingenuous in that the code for these first three implementations, it's not trivial code, and there's some very smart people that worked on it that made it work. But the fact that you can get there at all in Java should say everything, right? So when we talk about like what's the future of Java, I mean, I'm still savoring what we've already got in the last year.
Yeah.
We have let me see, stop the screen. We have a feature that just dropped in Java 22 called Project Panama, and so for many years, Java hasn't had really good interop with native code, right? If I wanted to talk to C or to talk to Go or Rust or whatever, every other language makes it pretty trivial to do that. Python, half of its SDK is written in C code because it's trivial to do so. And this is good and bad. It's good because you get good results yesterday, but it's bad because that code is not actually portable. You can't take it to another operating system unless you have an equivalent C binding for that plugin. In the Java ecosystem, we've never had that, and the reason is because it's so painful, it's so hemorrhoid-inducing to do interop with native code, right? And so we finally got this new foreign function interface that came in Java 22 6 months ago that makes it trivial now for us to look up symbols, invoke them, allocate memory pointers basically to set values in those memory regions, and then interop with native code to invoke them and get the results back and translate them back into Java. It's like a reflection API, but for C, right? So now I'm looking at this and I'm going, wait, I've got Go-like scalability with virtual threads. I've got GraalVM statically linked, self-contained, blazing fast native images, and I've got easy foreign function interop. I mean, like, let's build the next Cloud Foundry on that.
Absolutely.
Go anymore. There's no point. So I don't know. It's just an amazing place to be. If you had told me 10 years ago that this would be the JVM of today, I'd go, no way. But here we are. It's an amazing time.
All right, Josh. Well, we're coming up on the end of the show. I know that you got to go catch a plane. I want to get one question in. Fein's been waiting for this question. What Spring projects over and above native and Spring AI are you most impressed about? We can get that out early, get you on your way to your flight and to your coffee.
Spring Modulith. It's a project for describing, the reason we care about microservices and the reason we care about modularity is because it reduces the blast radius for change. If I make a change to this part of the code base, I don't want to negatively impact other parts of the system, and I don't want to have to involve other people, right? I want change to be fast and quick and easy. So if you have well-delineated sort of surface areas, boundaries in your system, then as long as I stay within that component boundary and make my changes within that, I don't have to synchronize with other parts of the organization, other parts of the team. And this is how you scale, is by being able to isolate your changes and not have to, if you have a stand-up and there's 100 people on the call, it's not a stand-up. You're going to need to sit down, right? It's too many people. So this is why people move to microservices, right? Is to have a forcing function to identify small self-contained bits of functionality on which small teams can work, right? Well, it turns out you can also get some of that benefit as long as you're disciplined in developing your code. You want to make sure that your code is modular and that you have nice, well-defined mechanisms for limiting the blast radius for change in your code base. And so Spring Modulith gives you some of those benefits of microservices, but within a large, sprawling, otherwise monolithic code base. And it's a really nice project. And I would start all Spring Boot projects with that today. I would start with Modulith first.
Excellent. All right.
I want to give a shout out to Enbu for the alluding to the make jar not war, and that was definitely my first Josh Long memory, where I believe in the pivotal sales process of previous employer, they flew you out to our office, and you did you did your live coding situation. This is probably at least 10 years ago now. And
good times.
Start that Spring.io, and I don't think anyone had seen anyone live code in a physical conference room before at that time. So
I'm not
shout out to your style.
Oh, thanks, man. But again, it wasn't me. I couldn't do. Our old friend Andrew Clay Schaefer, he used to call it the Josh Long experience. You can't do what I do with COBOL, right? If I tried to go up there and start.cobol.io or whatever, it just wouldn't. You can't do anything useful there. The only reason it works is because it's Spring. I can build a whole system in the 30 minutes I'm making jokes and talking to you. That would take most people a week in PHP or Python or Ruby or C or whatever. Right? It's not even the same game. It's not even the same, right? That's the only reason that works is I'm an idiot and I can still get stuff across the line very, very quickly with Spring.
Ironically, Cobalt is the reason I am not a developer. I started taking that and I decided this wasn't for me. So it's funny that you bring that up.
Well, yeah, whatever. I would just pick that as a easy punching bag. But you know what I mean? There's so many other languages out there where that just wouldn't work. I couldn't reliably do all that and then still tell jokes in so short a time. There's just so much ceremony and nonsense there.
Excellent.
Yeah.
Well, I think we are at time. We do want to thank everybody in the audience. We had a lot of lively comment in the audience today. Always, Josh, it's a pleasure, to hear you talk. Always entertaining. For all those in the audience, thank you. Make sure that you hit that, like and subscribe button so that you can see when new stuff comes out, who we're talking to next. So make sure that you hit those buttons out there. And then Nick, take us out, man.
Yeah, I'm putting links to all of our social channels and things out there. So if you want to follow, again, that'd be great. Quick call out. We are live next week from Karlsruhe, Germany at Cloud Foundry Day. So yeah, we will have a live show for you next week. And I think Anpu, he just gave us a new tagline because if you don't know Josh, we end the show with a CF by. So now we have to do CF by Josh mode. So this is gonna be great. So I'll do a countdown and then we'll do CF by. All right.
Okay.
And then
Bye,
thanks again. So 3, 2, 1, CF by
Josh
mode.
Josh mode.
Josh mode.